Okay, so then we're going to talk about our last two rules, which we've briefly brought up here and there. This is just going more in detail. So these are both what I call floaters. They just pop up randomly, and they don't go in a specific order like the others. So, at least not necessarily. So let's first talk about the zero exponent rule. So we've talked about this briefly when we were talking about the quotient rule. The zero exponent rule means that anytime you have a variable raised to a zero power, it equals 1. And where that comes from is the quotient rule. So if I look at, let's just do a basic quotient rule. If I have a to the fourth over a to the fourth, technically the quotient rule says I subtract 4 minus 4, which is 0, and a to the 0, right? Well, think about what this means division-wise, okay? If I have 5 divided by 5, 10 divided by 10, 20 divided by 20, 100 divided by 100, no matter what I divide by itself, it equals 1. So that's where the two rules come together. So some examples. 2 raised to the 0 power is 1. Now, if I look here, okay, number 1, the 0 power here, it only applies to the x. So x to the 0 power is 1, but I still have this 2. So 2 times 1 is 2. Number 2, I have a to the 0 power, which is 1, times b, because it's just b, times c to the 0 power, which is just 1. So 1 times b times 1 is just b. Number 3, 8 to the 0 power is 1, times m to the 0 power is 1, times n, 1 times 1 times n is just n. 4, t is just t, 4 to the 0 power is 1, t divided by 1 is just t. I know it's just crazy random, it's just one of those things. Number 5, okay, 53 is just 53, times p to the 0, which is 1, times t, times s to the 0 power, which is 1. So 53 times 1 times t times 1 is 53t. So there's the 0 power. Now the negative exponent law we talked about yesterday when we kind of did a brief review. The negative exponent law says that we can't have a negative exponent first off. So in order to make a negative exponent positive, that's the only thing we're trying to do is make a negative exponent positive, is we move it to the opposite location. And what I mean by that is if it's in the numerator, then in order to make it positive, I need to move it to the denominator. Just as if it was in the denominator, in order to make it positive, I want to move it to the numerator. Okay? Okay. So let's just practice some examples on this. So number 1, all I see is x to the negative 5th. In order to make x to the negative 5th positive 5, I'm just going to move it to the denominator. Now, when I move this to the denominator, to make it positive, I can't just leave the numerator blank. So the only way to make it without changing the value is put a 1. Number 2, I have 3m to the negative 2. So the negative exponent law only applies to the variable that it's attached to. So in this case, it's not attached to the 3, it's just attached to the m. So the only thing I need to move is the m to the negative 2. So 3 is going to stay in the numerator, and to make negative 2 positive, I'm going to move m squared to the denominator. Number 3, I have negative 7a to the negative 4th b to the 3rd. There's no other laws here, so all I need to do is clean up the negative exponent. So the only thing that needs to move is the a. So negative 7 and b to the 3rd stay in the numerator, and a to the negative 4 move to the denominator, but it becomes positive. If I look at number 4, so then we start introducing all the laws that we've been talking about. And I'm really not going to lie, it's kind of, there's many directions I could go, because like I said, the negative exponent law is a floater. I mean, you could put it anywhere technically. So I'm still going to follow the same steps that I would if I were solving these as mixed problems. So I'm going to go power, product, quotient, adding, subtracting, and then I'm going to treat the zeros and the negative exponents as floaters. So if I look at number 4, This is the product rule to me. I don't even notice the -7 until I take care of the product rule. So the product rule says I'm going to multiply my coefficient. 6 times -3 is -18. And then I have my product rule, which says I'm going to add my exponents. 8 plus -7 is +1. And see, it kind of takes care of the negative on its own. Will it always do that? Of course not. But that's when I take care of the negative law. So it's just kind of, I mean, yeah, I could have done this a little differently, but it just gets too messy for me. So I just like to keep it pretty basic. So if I look at number 5, and this is what I mean by it can get a little different. There's many ways I could do this, but truth be told, I'm going to treat it like the power rule, because I see the power rule before I see the negative rule. And you may be taught differently, so I don't want to confuse you. I'm not going to show you both ways because that's just too much information. So I'm going to treat number 5 like the power rule. Okay, so I'm going to distribute this -2 to everything inside. Remember, this 3 has a 1 power. So 1 times -2 is -2, so it's 3 to the -2. And then 3 times -2 is -6, so it's x to the -6. So now I see the negative rules. And if you look at it, they're both negative rules, so I'm going to make them positive. The only way to make them positive is to move them to the denominator. So this becomes 3 squared x to the +6. And then in order to clean it up, I'm just going to take care of that 3 squared. So it ends up being 1/9 x to the 6th. Now, there was another way to do this. It's just, at the end of the day, we do the same steps. They just might be in a different order. So it's not wrong. It's just a different way. So I'm going to do the same thing for number 6. I'm going to distribute the -2. So 1 times -2 is -5 to the -2. 2 times -2 is y to the -4. And here is where I see both of them as negative, so I'm going to make them positive by moving them to the denominator. 1/5 squared y to the 4th. And since 5 squared, I want to clean that up, so it ends up being y/25 y to the 4th. Okay, so now let's just practice. It's a mixed review. So if I look at number 7, again, I see this as a negative power rule. So I'm going to distribute the -2. So it's -8 to the -2. X is 5 times -2 is -10. And y, -4 times -2 is +8. So right here, the negative rule only applies to the -8 squared, -8, -2 squared, and the x -10 squared. So these are the two I'm going to move to the denominator, and y to the 8 is going to stay in the numerator. So -8 -2 squared becomes -8 squared, and then x to the -10th becomes x to the 10th. Of course, I want to clean up -8 squared. -8 squared is +64. So there you go. Number 8. To me, I don't see all of those negatives. I see the product rule. And the product rule says that I'm going to add my exponents. So if I look at the A, I have -5 plus 7 is +2. B, I see 8 plus -3 is +5. And C, I see -12 plus 7 is -5. Now here is where that negative rule pops up. So the only one I need to move is the C. To make it positive, I'm going to do a squared b to the 5th and move the C to the denominator to make it positive. So there you go. Honestly, that's a way shorter way than what I was going to do. So it's just keeping it simple. I like to keep it simple. So number 9, I see power rule and product rule. So I'm going to distribute the power rule, so the -2. So x 2 times -2 is -4. 3 times -2 is -6. I have the product rule here. 5 times -3 is -15. And then 4 times -3 is -12. again, I don't see the negatives yet. I see the product rule. So I have to take care of the product rule first. So I'm going to add my exponents. -4 plus -15 is -19. -6 plus -12 is -18. And now that I have my bigger rules taken care of, I'm going to clean my negatives up. In order to make both of these positive, they are both going to move to the denominator. So I have x to the 19th and y to the 18th. Okay. Number 10. So I see the power rule and the addition rule. So we are going to take care of the power rule first by distributing. So this is 4 to the -2. 3 times -2 is -6. 6 times -2 is -12. Plus 2 to the -3rd. 2 times -3 is -6. And 4 times -3 is -12. Now, technically, I still see the adding and subtracting rule first because they are the same last name. Ooh, but this is where it gets tricky because of the two -3's. So what ends up happening here, this is nutso, isn't it? So what ends up happening here is because these -2's, these coefficients have negative exponents, I'm going to go ahead and make all of them positive by moving them to the denominator. Okay, so this ends up being 1 over. Now I want to make this positive, so that's 4 squared, x to the 6, y to the 12, plus 2 to the 3rd, x to the 6, y to the 12. Because I want to clean up these coefficients right here. So 4 squared is 16, 2 to the 3rd is 8. Now I can add these two together because they have the same last name. So it ends up being 1 over 16 plus 8 is 24. X to the 6th, y to the 12th. So this one was kind of messy in the way that it was set up, but it happens. Number 11, okay, it's just a simple quotient rule. This is where my little shortcut comes in handy so I don't have to deal with negatives as much. So my tip to you would be, when I have the quotient rule, I like to circle the higher power. So 6 is the higher power. I'm still going to subtract, but I'm going to subtract 6 minus 4 instead of 4 minus 6 because they are different. 6 minus 4 is positive 2. But how I know where my answer is going to end up, where h is going to be, is with the higher power. So h squared ends up in the denominator. Now, of course, I can't leave the blank on the numerator, so we're just going to put a 1. If I look at number 12, which one is the higher power? -2 or 7? And 7 is the higher power. Now, this is where you have to be careful when you're subtracting because it's 7 minus -2. Not just 7 minus 2, it's 7 minus -2. So if you're not good at your negatives, 7 minus -2 is positive 9. And positive 9 is going to go at the denominator because 7 was larger, and then 1 goes in the numerator. Okay, so I'm going to take that same idea with the rest of these. So if I look at number 13, okay, first I'm going to simplify my coefficients. 14 over 7 is 2, okay. Then I look at the w's. 4, -2. 4 is the larger exponent, or higher exponent, I guess you can say. So now I subtract. 4 minus -2. Again, if you're not too good at negatives, 4 minus -2 is positive 6. But w to the positive 6 is going to be in the numerator because that's where my higher power was. 14, -24 over 3 is -8. And then if I look at my x's, 5 is the higher power. 5 minus -2 is positive 7. So it's going to end up on the numerator as well because 5 was the higher power. Then I look at number 15. 15, I have b squared over b squared. Think of it. 5 divided by 5, 10 divided by 10, 100 divided by 100. Those technically cancel, but I don't like to use the word cancel because it doesn't always happen. But those technically cancel and simplify to 1. So nothing really happens there. But then I have c to the 1 and c to the 5th. c to the 5th is the higher power. So 5 minus 1 is 4. It's going to end up in the denominator because 5 was bigger, but I have to leave 1 in the numerator. I can't just leave it blank. All right, number 16. I have x to the 4th over x squared. 4 is the higher power, so 4 minus 2 is 2, but it's going to be in the numerator. Then I have y to the negative 3rd and y squared. 2 is the higher power, because remember, higher means further right on a number line. So 2 minus negative 3 is positive 5. But the y to the positive 5 is going to be in the denominator because 2 was higher. So you have to always put it with the higher power. 17, 32 over 8 simplifies to 4. Okay. Then I look at the a's. I have 5 and negative 2. 5 is the higher power. 5 minus negative 2 is positive 7. So a to the positive 7 ends up in the numerator. Then I have b is negative 3 and b is 6. 6 is the higher power. 6 minus negative 3 is positive 9. But b to the positive 9 is going to be in the denominator because 6 was higher. Okay? And the only reason I do this trick is because it avoids messy negatives. Not that negatives are difficult, it's just it avoids that step. So it just skips a step. 18, 36 over 12 is 3. Okay, now if you look, the only x available is x to the negative 4. So I'm going to go ahead and leave it where it's at. And then my y's, 8 is higher. 8 minus 7 is 1, so y is on top because 8 was higher. But then I can't leave it like this because I have a negative exponent. So I still have to deal with negative exponents. But 3y stays in the numerator. And to make negative 4 positive, I'm going to move x to the denominator to make it positive. Okay, a few more quotient rule examples, and then we're going to mix it up. 15 over 18 simplifies to 5 over 6. If I look at the a's, a over a simplifies to 1, but I'm not going to write a 1. B's, 5 is the higher power. 5 minus 3 is 2, so it's b squared in the numerator because 5 was higher. C to the 8th over c to the 9th. 9 is the higher power. 9 minus 8 is 1, and it's going to end up in the denominator because 9 was higher. And I'm just going to put c because to the 1 power is the same thing. Number 20, negative 4 over 8 is negative 1/2. Okay. P, I have 1 and 2. 2 is the higher power. 2 minus 1 is 1. And P is going to be in the denominator because 2 was higher. Q, 5 is the higher power. 5 minus 2 is 3. And Q is going to end up in the numerator because 5 was higher. R, 3 and 10. 10 is the higher power. 10 minus 3 is 7. It's going to end up in the denominator because 10 was higher. And there's your answer. I'm not going to do anything with the negative one because the negative rule only applies to negative exponents, not coefficients. Okay, one more quotient, and then we're going to go over mixtures. Negative 9 over 54 is negative 1 over 6. R, I have 2 and 5. 5 is the higher power. 5 minus 2 is 3, and it's going to end up in the denominator because 5 was higher. S, 6 and 2. 6 is the higher power. 6 minus 2 is 4, and it's going to end up in the numerator because 6 is the higher power. T, 4 and 8. 8 is the higher power. 8 minus 4 is 4, and it's going to end up in the denominator because 8 was higher. And there's nothing to clean up here because they're all positive. Negative 1 does not apply to the negative rule. Now let's do 2 examples where we get a mixture. So we're going to follow those orders of operations. We're going to do power, product, quotient, add and subtract, and the negative and 0 are going to be our floaters. So let's look at 22. So I see the product rule in the numerator and then the quotient rule. So this one's not too bad to start. So we're first going to take care of the product rule. Product rule says I'm going to multiply. 6 times 5 is 30. And then I'm going to add my exponents. So 3 plus 9 is 12. Nothing happens to the denominator because it doesn't have the product rule. Now I take care of the quotient rule. 30 over negative 12 simplifies to 5 over negative 2. And the quotient rule, so 14 is higher. 14 minus 12 is 2, but it's going to be in the denominator because 14 was higher. 23. So I see the power rule, the product rule, the quotient rule. This is a popular one, that combination. So power rule first. I'm going to distribute this 2 to all of the powers inside. And all of the powers are 1. So 2 times 1 is 2, so that's 3 squared. 2 times 1 is 2, so that's x squared. 2 times 1 is 2, so that's y squared. I'm going to go ahead and clean up this 3 squared, so 3 squared is actually 9. This is not the power rule, so I'm going to bring it down. 2x to the 4th, y to the 3rd. Oops. Over 6x to the 8th y. All right, now I have the product rule on the numerator. 9 times 2 is 18. Add my exponents, so 2 plus 4 is 6, and 2 plus 3 is 5. Then I'm going to bring down that denominator again. Now I have my quotient rule. 18 over 6 is 3. 6 and 8, 8 is higher, so 8 minus 6 is 2, but x is going to be on the new denominator because 8 was higher. And then 5 and 1, 5 is higher, 5 minus 1 is 4, but y is going to be in the numerator because 5 was higher.